Hi, welcome back. The problem today is a definite interval. And for the video today, I will introduce you a special method to resolve this interval. Now, let's get started. First of all, we have to rewrite the interval. That's the interval 1 to e power pi of cosine L and x dx. So, as this interval that is something like a special form of the interval, so we have to do this by following approach. First of all, we put this interval as the eighth, and we consider another interval p as the same domain is the 1 to e power pi, but we have the sine L and x dx. And we just think about that is the pair of the interval. They will have the dependency together. We will apply a few methods to convert this into a system equation of the ma plus np equal to something case and a to plus pp equal to c. Then we solve this system equation. By this way, we will receive the a and also the p. Then we have the value of the interval in the problem. So we just rewrite the interval a. Remember that we have u is u and a function and v is another function, and its derivative will be equal to u multiply dv and not dv, u v derivative and plus u derivative multiplied by v function. And if we apply this, it will be uv equal to plus interval of derivative v multiplied of u. Then we will put the substitution variable that is u equal to cosine L and x and dv equal to dx. Then we will have the du equal to 1 over x multiply sine L and x dx. Similarly, for the v, we will have v equal to x. Sorry, this is -1. Then we apply this u multiply by v is either x multiply cosine L and x will be equal to dv multiply cosine ln x. It means dv equal to dx. It means the interval of the problem 1 is pi. That's 1 e power pi plus dv multiplied by u. This is equal to 1 e power pi negative sine ln x dx. So this on the left side we will have x cosine ln x 1 e power p plus this is move to the right, it will become p, the interval p, this one. Then and the left is the interval 8, the right is will interval 8. So we just calculate this value. This is will be e power pi multiply cosine pi minus cosine 0, then plus p equal to a. This will be negative e power pi minus 1 plus p equal to a. That's the equation 1. Similarly, we do the same for the p. We put u equal to sine ln x and dv equal to dx. Then we will have the second equation is x sine ln x from 1 to e power pi and minus a equal to b. So this will be e power pi is sine of pi minus sine of 0. Then pole 0, then negative a will be equal to b. That is the second equation. And from 1 and 2, we have the system of equation. We have a equal to b minus e power pi minus 1 and a equal negative b. So then we can find the value of a equal to negative e power pi minus 1 divided by 2. So the value we need to find for the integral at the problem, that's a negative e power pi minus 1 over 2. And the extra thing, then we can calculate the value of the integral p. It's e power pi plus 1 over 2. as is the extra thing we can do for this problem. So the lesson of this problem, this kind of integral, that we may apply this approach by checking the pair of the interval that usually apply when we have the trigonometry function, something like sine x and cosine x. Then based on that, we can use another pair of the interval like sine x and cosine x and apply this formula. Then we can solve it by the system equation. Finally, we find both value of a and b. So that's it. Thanks for watching. See you later. Bye.